So okay, so let me share my screen. This is the code. Can someone confirm me that whether you are whether you see PyCharm coding window or Visual Studio Code window? Can someone confirm? I have some problem in my Zoom. Which ID I have? I have opened two IDs.
It is PyCharm.
PyCharm. Okay, thank you. Okay, so so this is the code I wrote yesterday for image addition part 2. If I run this, this will be the result. So I resize the logo so that I can move the window around. So yesterday I had a tough time explaining these things because the window was so small. So now I can arrange clearly. So this is what happened. You should have the understanding of mask clearly, right? What is mask? Mask is something that we are going to use with AND operation, right? What happens in AND operation? Let me explain, right? So first, this logo is read by this code, right? So logo, and it will be thresholded. So this is a thresholded version of this mask. Sorry, this logo. So as you can see, this foreground part will be in white, and the background will be in black, remain black, right? And this FG has been determined using these two, using logo and mask. Using how I achieve this FG is that by performing logical and between these two, right? Between these two, right? That is what this CV2 dot CV2 dot bitwise AND operation does, right? So the result will be so this output will be the result, this BFG. It outputs in such a way that all the region which are in white, will be appear in the result, right? That's how this bitwise AND operation functions, right? So similarly in this ROI and mask inversion, right? ROI and mask inversion, right? ROI and mask inversion. Mask inversion was determined using bitwise not operation, right? So this is the opposite of this. Mask inversion is the inverse version of this mask, right? So this is inverted one. All the regions where the white, where the color is in white, will be in black in this mask inversion, right? මෙතන mask එකේ තියෙන්නේ mask එකේ සුදු තිබ්බ දැන් මෙතන කළු වෙලා තියෙනවා. කළු තිබ්බ දැන් සුදු වෙලා තියෙනවා. හරි. ඒතර මේක තමයි bitwise not එකෙන් එන්නේ ඒකේ inverted එක. හරි. එතකොට මේ mask එකේ inverted එක තමයි mask inverted කියන්නේ. එතකොට ROI කියන එක තියෙනවා. ROI කියන එකක් අපි මේ මෙන්න මේ region එක තමයි ROI මම ගත්තේ. එතකොට මේ තියෙන ultimate result එක. එතකොට ROI එකයි mass inversion එකයි bitwise AND කරාම BG කියලා එකක් හැදෙනවා. එතකොට මේකෙත් වෙන්නේ සුදු පාට තියෙන තැන් මේ ROI එකෙන් extract කරගන්නවා. එහෙම තමයි කරලා තියෙන්නේ. සුදු පාට තියෙන තැන් තියෙනවනේ මේ තියෙන mass inversion එකේ mass inv එකේ සුදු පාටින් තියෙන තැන් ROI එකෙන් ගලවලා ගන්නවා. ඒක තමයි මෙතන කරලා තියෙන්නේ. So what happened here is the white regions in the white region in the mass inversion will be extracted from this ROI, right? ROI. So that's how this BG has been determined, right? Finally, what I did was I simply add these two FG and BG, right? The addition of FG and BG result in DST. DST is something like this, right? This is DST. So then what I did was copying this DST image. That's how I ended up with this image, right? එතකොට මේ mask කියන කතන්දරේ ඔළුවේ තියෙනවා. mask එකක් කියන්නේ binary image එකක්. Mask is a binary image where each value lies between 0 and 255. Mask එකේ තියෙන්න පුළුවන් values 0 හරි 255 හරි විතරයි. එතකොට ඒක තමයි binary කියන්නේ. binary image එකක් කියලා කියන්නේ. එතකොට මේ understanding එක ඔයාලට තියෙන්න ඕනේ. ඒ කියන්නේ mask එකේ white කියන තැන තමයි ගලවලා ගන්නෙ මෙතනින්. mask එකේ white කියන තැන තමයි මේ මෙතනින් ගලවලා ගන්නෙ. ඒතකොට මේ මෙතන කරලා තියෙන්නේ ඒක. දැන් මෙතනත් white තියෙන තැන් වලින් තමයි මෙතන මේ image එකේ ගලවලා ගන්නෙ. හරි. එතකොට මේ වගේ image එකක් හැදෙනවා. හරි. එතකොට මේ white තියෙන තැන් ගලවලා ගන්නවා. එතකොට black තියෙන තැන් black විදියට තියෙනවා. එතකොට මේ වගේ BG කියලා එකක් හැදෙනවා. එතකොට මේක තමයි image addition එක part 2 එක. මොනවාරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න. So I have another image in my folder which is logo1.png. So I created the resize image of logo PNG, which is in higher dimension than this one. So this is in higher dimension so that I can move around the window to explain you clearly what's the theory. So this one is white in this one has the white in background, right? So the earlier one is black in earlier one was the black in background, right? Background was in black. So the next image that I want to use is in white in background. Background color is white. So let's use this one. Let's see how to. So we have to do a small change here. So I'll post this code to the chat in case you don't have it. So this is the code. So here as I said before, the background is white. The background of the logo image is white. So how to handle this case, right? So for that, I think we have to use binary inverse, threshold binary inverse. Binary inverse. first I have to read the file logo 1.png. Logo1.png. So it is white. Its background is white. Foreground is the Python image, Python logo. So the threshold, global value of the threshold will be 230. I'll determine it as 230. This should be test binary in. Then only you can threshold it properly, right? If you can't understand this one, let me know. I'll explain. Then the 230 and test binary in. Now let's see what happened. Now as you can see, so this is the logo. Previously the background was in white, so now it is, sorry, previously background was in black, so now it is white. So this is a mask. So we have thresholded it properly, right? So if I use threshold binary in and 10, same as the previous one, let's see what will happen. The mask will be fully white, right? Mask will be fully white. We don't need such case, right? It should be 230 and 230, 240, 220, something close to 255, right? Will work. So if I run this, so as I said before, the region where the white pixels are in mask will be appeared in the logo, from will be extracted from the logo. So මෙතන සුදු පාට තියෙන දැන් මේ මාස්ක් එකේ සුදු පාට තියෙන තැන තමයි මෙතනින් ගලවලා ගන්න. ඒතර මෙයාගේ සුදු පාට තියෙන තැන ටික ගලවලා ගත්තට පස්සේ සුදු පාට තියෙන regions මේකේ logo එකෙන් ගලවලා ගත්තොත් මෙහෙම එකක් හැදෙනවා. background එක කළු පාටයි. foreground එක Python image එක. ඊට පස්සේ මේකේ inversion එක තමයි මේ තියෙන්නේ mask in කියන. ඒතකොට මේකේ ROI එකේ bitwise and එක ගත්තට පස්සේ මෙහෙම එකක් හැදෙනවා. හරිද? මේකේ වෙන්නේ මේකෙත් අර මම කිව්වා වගේ මේ ROI කියන එකෙන් ගලවලා ගන්නවා මේ mass inversion එකේ සුදු පාටින් තියෙන තැන්. මේ සුදු පාට තැන් තියෙනවා ROI mass inversion එකේ සුදු පාට තියෙන තැන් තියෙනවනේ ඒ වගේ තැන් ටිකක් තමයි මෙතනින් ROI එකෙන් ගලවලා ගන්න. ඒතකොට මෙහෙම එකක් හැදෙනවා. ඊට පස්සේ මොකද කරන්නේ? FGBG එකතු කරනවා. එකතු කරාට පස්සේ මෙහෙම එකක් හැදෙනවා. මේ දැන් එකතු කරාට පස්සේ මෙහෙම එකක් හැදෙනවා. මේ කළු පාට ඒවා එකතු කරාට වෙනසක් වෙන්නේ නැහැ. කළු පාට එකතු කරාට පස්සේ වෙනසක් වෙන්නේ නැහැ. එතකොට මේ මෙහෙම එකක් හැදෙනවා. DST කියලා හැදෙනවා. ඊට පස්සේ DST එක අපි image එකට set කරගන්නවා. ඒක තමයි මේ මෙතන වෙන්නේ. මොනවාරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න. That's the idea about mask, right? We need that understanding of mask so that we can continue this workshop. For the color detection, we need mask. So that's about this code. Next, I would like to recall the same code I used on the same code. Any edge detection. Import CV2 image equal. I'll read the car.jpg. c2.inread r.jpg. So c2.weight key, c2.inshow image c2.weight key 0 c2.destroy all windows. So let's see what will happen. So car image will be open. So I want to see the canny edge detection of this image. For that, I will call canny edge detection canny c2.canny. Here you have to pass the image. Then you have to pass the threshold values. Threshold, for the threshold one, I will use 50. For the threshold 2 also, I will use 50. So let's visualize canny. So this will bring you the edge image. So just are highlighted in this image, right? So you can play with these threshold values. So for example, 150. So the edges are reduced, right? Just have been reduced. Yes, you can play with these numbers. So I don't know whether, yeah, 250, 150. You can play with these numbers and see the result. This will be useful. So I did a course called self-driving car nano degree. So in that course, it is a self-driving car project. So for the lane detection part, we use canny edge detection for detect the edges, and so there are some use cases for the shape detection as well. We need canny edge detection, right? There are lots of use cases for canny edge detection. We can use anywhere where we need edges, right? Okay, so this is about canny edge detection. Okay, today I will continue the workshop with warp perspective. Warp perspective. For this section, I'm going to use this image, cards.jpg. What I'm going to do is I want to see this jack, this card from the top right. I want to see if this from the top, that is like this. I want to see like this, right? So this how to do that, right? So the card is somewhat aligned, right? I want to see from the top, right? So let's see how to do this. For that, first you have to open this using Paint, right? I will open this using Paint. Then you need to write down the coordinates, right? coordinates of the corners of this card. For example, this corner, the point, look at the pointer, mouse pointer. So the coordinate will be displayed here, right? So if I hover the mouse over this corner, so the pixel value will be 509, 225. Sorry, 125. This corner will be 823, 207. Right? Likewise, you have to record these four corners. Right? We start from this corner and then next this corner, then this corner, and finally this corner. So I have recorded those values. These are the values. These are the values coordinates I got from Paint software. These are the coordinates. Check whether this match with your case, right? So we need these coordinates, right? Let's import CV2. Then we need NumPy as well. Import NumPy as MP. Let's read that card.jpg image, cv2.ingrid cards.jpg, right? So next we have to store these coordinates in an array, in a NumPy array. These coordinates in a NumPy array. To do that, we need np.float32. We need float32, otherwise there will be an error. Float32. The data type will be float32, and the coordinate will be coordinate should be enclosed with square bracket. These are the coordinates, something like this. So this will be the points 1. I will say points 1. Okay, so normally card, so this playing card has the aspect ratio like 2.5 to 3.5, right? So I will use this width and height of the resultant image as 250, 350, right? Considering the aspect ratio, I chose this one, these values. Next, so again, I'm going to the Paint software. So we got the point from from we started gathering points from this point, this point, next this point, next this point, finally this point, right? So this order should be taken care, right? You have to follow this same order for next thing as well. Which is PTS2. In P.float32, then you have to start. So here what I'm going to do is these are the points of the resultant image, right? That is this image. That is this image, right? I need to specify the points of this image, right? Coordinates of this image. 0, 0, 0, width, 0, and this point will be width, height. This point will be what is that? 0, height. 0, height. Right. This point will be, so we already define width and height here. The resultant image width and height, right? We selected these two parameters as width and height. So here 0, 0. Next width 0. With this point will be width and height. This point will be 0, height. Right? So let's put them 0, 0. With 0 with height 0, height. The resultant image එකේ දැන් මේ image එකේ අපි ගත්තනේ order එකක්, මේ points ගත්ත order එකක් තියෙනවනේ. මේ point එකෙන් පටන් ගත්තා, ඊට පස්සේ මේ point එක, මේ point එක, මේ point එක. ඒ points පිළිවෙලටම ඒ ගත්ත පිළිවෙලක් තියෙනවා. ඔයා මේ point එක අරගෙන මේ point එක අරගෙන මේ point එක ගත්තා නම් මේ point එක අරගෙන මේ point එකට ආවම ඒ පිළිවෙලම ආයෙ පාවිච්චි කරන්න ඕනේ. ඒතර මම ගත්ත මේ පිළිවෙල. මේ point එක ගත්තා, මේ point එක ගත්තා, මේ point එක ගත්තා, මේ point එක ගත්තා. ඒතර ඒ පිළිවෙලම resultant image එකේ ගන්න ඕනේ. resultant image එකේ පිළිවෙල එන්නේ එතකොට කොහොමද? resultant image එකේ width එක height එක තමයි මේ තියෙන්නේ. එතකොට ඒකේ පිළිවෙලම ගත්තොත් එහෙම බිඳුව බිඳුවෙන් පටන් ගන්නවා. ඊට පස්සේ width බිඳුව වෙනවා. හරිද? width බිඳුව, ඊට පස්සේ width height, ඊට පස්සේ බිඳුව height. හරිද? ඒ පිළිවෙලට එනවා. හරිද? Next, what I'm going to do is I'm going to calculate the matrix needed for this warp perspective, right? For that, CV2.get perspective transform. The first parameter will be source. Source will be get vast perspective transform. Source points will be PTS1, and the destination point will be PTS2, right? So this make matrix එක ඕනේ මේ vast perspective එක කරන්න. හරි? මම ඉස්සලා අපි matrix එක හදාගෙන ඉන්නවා. හරි හදාගෙන ඉන්න නම් මැට්‍රික්ස් එක හදාගන්න පොයින්ට්ස් ටික දීලා ඉන්නවා. ඒතර මේවා තමයි පොයින්ට්ස් ටික. හරි මේවා තමයි පොයින්ට්ස් ටික. එයා ෆ්ලෝර් 32 වලින් තමයි ඉනිෂියලයිස් කරලා තියන්න ඕනේ. ඒතර ඒ පොයින්ට්ස් ටික අරගෙන මේ get perspective transformation එකෙන් transform වෙන්නේ මැට්‍රික්ස් එකක් හදාගන්න. මැට්‍රික්ස් එක හදාගන්න. ඊට පස්සේ image output එක image output will be cv2 dot var perspective. So the first parameter will be image. Second parameter will be the matrix. Third parameter will be the destination size, right? Size will be width comma height, right? Width comma height. So let's visualize this. cv2 dot show image cv2 dot show output will be output එක මොකද මගේ image output නේද image output cv2 dot weight key 0 cv2 dot destroy all windows. Let's run this. So this is the result, right? This is what I wanted to this is what I wanted, right? If you need to save this, so one student asked me how to save the file after the required operation. You can do this by issuing cv2.inwrite and the file name. I would say result.jpg and then in the matrix, right? Array will be the variable will be image output. So if I run this, so there will be a file generated with this name. Let's see. This is the file, right? Result.jpg. In this way, you can write save the required image in your drive, right? So there is one more question. When selecting the coordinates, don't need to consider positive or negative XY direction. When selecting the coordinates, don't need to consider positive or negative XY direction. Let's see. When selecting the coordinates, don't need to consider positive and negative XY direction. Yeah. So to answer your question, we need to consider the order. So the same order use we can මෙතන ඔයාලා point ගන්න order එකක් තියෙනවනේ. ඒ order එක receive කරගන්න ඕනේ. මේ order එකෙන් තමයි ගන්න ඕනේ. එතකොට ඔයා අහන්නේ negative, positive and negative xy direction. Positive and negative xy direction. කියන්නේ positive direction එක තමයි මේ පැත්තට තියෙන්නේ. ඒ කියන්නේ negative axis කියලා එකක් නැහැ කොහොමද? positive axis එකනේ තියෙන්නේ. එතකොට මේ පැත්ත positive ප්‍රශ්නේ තා පොඩ්ඩක් ප්‍රශ්නේ ඉස්සර කරන්න පුළුවන්ද? Can you explain your question more? Did I answer your question? Positive and negative xy direction. So output image top corner is assigned as 0, 0, but the other corners are below. Since yeah, so this top corner will be always 0, 0, right? So this corner will be 0, 0. So as you can see here, so look at the values generated in this section. The place where I am holding my mouse, right? This is where the place the coordinates are showing, right? So in this position 0, 0. So it will be 0, 0, and other corners are below. Other corners are below. Below means toward this direction, it will be considered as positive direction. The x-axis will be inverted in this case, right? Y-axis will be y-axis will be inverted in image processing. Y-axis will be inverted. X-axis will be remain same, right? So y-axis will be inverted like this. Positive direction of the y-axis is as follows. ඒ කියන්නේ y-axis එක හැමතිස්සෙම පල්ලෙහාට තියෙන්නේ. y-axis එකේ බිඳුව තියෙන මෙතන, x-axis එකේ බිඳුව ඒ කියන්නේ බිඳුව කෝණයට හැමතිස්සෙම එන්නේ මෙතනට. එතකොට එතන බිඳුව එනවා අනිත් කෝණස් ඒ කියන්නේ මේ අනිත් මේ පැත්ත බිඳුව මේ පැත්ත width and height point එක වෙනවා. එතකොට but other corners are below. What do you mean by below? Do you mean whether it is negative? You got it. Okay. 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 So Okay, this is about vast perspective. Next thing that I'm going to talk about is color filtering, right? Color filtering. I'm going to delete these things. Uh, uh, okay, so let's import CV2. If you need this code, I will post them into chat. Right, so fast perspective V2. Now we are going to do color filtering. Import CV2. We need numpy as well. Import numpy. Okay, let's read the image. Image equal CV2 dot read. So there is a photo for this flower.jpg. So this is the page, this is the photo I am interested in. So let's use this flower.jpg, right? Flower.jpg. So this is the new thing for you. Image HSV CV2 dot CVT color. So we are going to use a different color space, right? CV2 dot BGR2 HSV BGR2 HSV. So BGR2 HSV. So we are using this HSV color space. HSV means hue, saturation, and value. Hue, saturation, value. HSV කියන color space එකක්. RGB කියන අපි පාවිච්චි කරන මෙච්චර වෙලා. දැන් මේ HSV කියන color space එකක් තියෙනවා. So far we use RGB color space. So from this point onwards, we are using HSV color space, right? So if I visualize this color image, so it will be strange. Strange for you. CV2 dot show image will be image and image HSV image HSV CV2 dot AT0 CV2 dot restore all windows. Let's run this. Sorry, color BGR to HSV. It should be color BGR to HSV. Right? Run this. So this is the image we are interested in. This is the HSV of this HSV. So this this is how the HSV for version of this photo look like in RGB color space, right? This inshow function always visualize in RGB color space, right? So this is useless, right? This visualization is useless, but I just showed you. එතකොට මේ HSV කියන color space එකක් නේ අපි පාවිච්චි කරන්නේ. ඒතර HSV color space එක RGB එකෙන් පෙන්වුවාම වෙන්නේ මේ විදිහේ රූපයක් තමයි එන්නේ. හරිද? එතකොට මේක අපිට වැඩක් නැහැ මේක. ඇත්තටම මම නිකන් පෙන්නුවේ. Yeah, so then my target is to filter this red color, right? This red color, right? මේ මලේ පෙති ෆිල්ටර් කරගන්න දැන් මට ඕන රතු පාට තියෙන පෙති. හරිද? එතකොට ඒක කොහොමද කරන්න කියලා බලමු. හරිද? So my target is to filter out this red color from this image. So let's see how to do that. So to do that, we need to use track bars for this track bars. So as you can remember, if you can remember, yesterday we used track bars for thresholding, right? So we had to use the same thing today as well, right? cv2 dot name window. We have to create a window for that. Track bars, I call it as track bars, the window. Then I have to create track bars, right? cv2 dot create track bar. First one will be hue min, right? You will understand what I'm doing after this section. Hue min, just follow along with me. Hue min, I just copy and paste this, right? So empty will be dummy function, something like this, right? So I have created six track bars, namely hue min, hue max, sat min, sat max, well min, well max, right? Hue min, hue max, saturation min, saturation max, value min, value max, right? We are needed these track bars for this color filtering application, right? So the next parameter will be the window name. Window name will be track bars, right? Track bars will be the window name, and this value will be the default value in the track bar, right? So for the hue normally range between 0 to 179, right? 179, right? So there are the rest of the values will be range from 0 to 255, 0 to 255. So the max value will be 179 for hue, max value will be 255 for saturation, max value will be 255 for value as well, right? So this is the track bar. So let me show you the track bar. There's a problem. What is it? Track bars. B should be capital. Bars. Now I think it should Okay. Yeah, this is the track bar. Hue mean hue max, saturation max, value mean value max, right? මට තේරෙන්නේ ඇයි මේක 255ට යන්න ඕනේ දැන් මෙතනට යන්න ඕනේ මේ පොයින්ට් එක මොකද දන්නේ මෙතනින් අතර වෙලා තියෙන්නේ. ඒක මට ප්‍රශ්නයක් මොකද කියලා. අනිත් ඒවා නම් හරි. දැන් ට්‍රැක් බාර් එකක් කියන්නේ ඕක තමයි. හරිද? එතන මේ ටික ඔයාලා ටයිප් කරන්න. එතකොට okay, so okay, so next thing that I'm going to do is I need a while loop, infinite loop. දැන් අපි මේ කරන්න යන්නේ මොකක්ද දන්නවද මේ color detection කරගන්න අපිට මේ HSV values දෙකක් ඕනේ. එකක් තමයි lower bound එක අනිත් එක upper bound එක. To filter out colors we need two HSV values. They are called upper bound and lower bound. Upper bound and lower bound, right? Upper values and lower values, right? So that's why I created six track bars, right? For the minimum, 3 for minimum and 3 for maximum, right? 3 for minimum and 3 for maximum. These 3 for minimum, these 3 for maximum, these 3 for maximum, right? So that's why I created these six track bars. So next thing is H-min. So I need to have the variable to get the track bar values, right? So H means to store the value of the H mean. Q mean I need to save this H mean. H mean equals cv2 dot get track bar position. Then the track bar name will be u mean. Window name will be track bars. So I will duplicate this 6 times. Okay, then u mean umax. Tag bar name is umax. Then next thing will be saturation mean. Saturation mean will be sat mean. Saturation max will be set max. Value mean value max. Value mean val max. So where these names come from? So track bar name, right? You mean, Umax, Umax, right? Set mean, set max, set mean, set max, well mean, well max, right? So this is to store the value from the track bars, right? Uh, so we can print these values. Let's run this. That's this that. So it should be B, capital B. Capital B. Okay, let's run this. What's the error? This one should be U. Now it should be okay. Still session fail. This should be set as typo. Let's run this. Now okay. Now I'm getting the values, right? So this is infinite loop. Program crashes. Okay, everything is okay. Let's add the condition to break the loop. CV2 dot T0 -1 break. Okay, let's run this. It should be 1 millisecond. So let's see whether we are getting values. Yeah, U mean works. U max works. Saturation min works. Saturation max is also working. Value min working. Value max is also working. Yeah. Now we are good to go. Okay, so next what I'm going to do is define the lower bound and upper bound. Lower np.array lower bound will be HMIN, SMIN, value min. Upper bound will be upper equal H max, S max, V max. Okay, so I'll delete this. These are the upper value and lower values, right? Next will be mask equals CV2 dot in range. So we are calling in range function, right? In range source will be image HSV, this image, right? This image HSV, and next the lower bound will be lower and the upper bound will be upper. Yeah, so let's ensure this C2.ensure mask. Okay, so let's see whether it's working. So when I'm changing these values, right, you can see mask will be working, right? Mask will be changing. Okay, so same as before, same as the previous code, CV2 dot I'm going to use bitwise and here I will pass image, then again image, then mask will be mask. Mask will be mask, and this is the result image. Resultant image. Result. So let's visualize this. CV2.ensure result image result. Okay. So මෙතන මම කරන්නේ මේ upper boundary lower boundary හදා ගන්න ඕනේ HSC values දෙකකින්. මේ දෙක අරගෙන මේ දෙක use කරලා mask එකක් හදා ගන්න. mask එක හදාගන්නේ CV2 වල in range එකකින්. ඒ කියන්නේ මේ දෙක ඇතුලේ තියනවාද කියලා බලන එක තමයි මේ in range එකකින් කරන්නේ. upper bound එකයි lower bound එක ඇතුලේ මේද තියෙන්නේ කියලා බලලා binary image එකක් generate කරන එක තමයි masking in range එකකින් කරන්නේ. So the goal, the idea behind this code is, this code segment is, it checks whether the image, the particular image, this image HSV, right? In this case, image HSV, whether this image HSV is in between this lower bound and upper bound, right? If it is in between this lower bound and upper bound, it will generate 255. Otherwise, it will generate 0, right? So it checks all the pixel values, each pixel values, right? It will check each pixel value whether it is in between this range, right? If a particular pixel value will be in this range, if a particular value will be in this range, it will generate 255. Otherwise, it will generate 0. And that's the idea behind this code segment. Then what I did was I used cv2.bitwise and to use this mask against image, right? අර මම හදාගත්ත මාස්ක් එක මෙතන හදාගත්ත මාස්ක් එක පාවිච්චි කරලා මාස්ක් එක පාවිච්චි කරලා resultant image එක හදාගන්න එක තමයි මෙතන කරන්නේ. හරි. මාස්ක් එක අරගෙන අර මම කියවන්න සුදු පාට region වල විතරයි සුදු පාට region තියෙන තැන් විතරක් අර image එකේ ගලවලා ගන්නවා කියන මම අර කිව්ව මතක ඇති ඉස්සෙල්ලා කතාවේ ඉස්සෙල්ලා කෝඩ් එකේ. හරි. ඒකම තමයි මෙතනත් කරන්නේ. ඔයාලට ඒක දැනගන්න පුළුවන් මේක කෝඩ් එක රන් කරලා පස්සේ. ඒතකොට මේක තමයි කෝඩ් එක. So let's run this, right? So this is the image, right? This is the HSV. These two are not needed. We need these two. So so my target is to filter out this red region, right? So for that, so I will change this little bit. රතු පාට ඩිකේ වෙන්න හදනවා නම් හරිද? රතු පාට ෂේ වෙලා යන්න හදනවා නම් නවත්තන්න. හරි. If the red region tries to decay, just stop it, right? So මෙතන මේ මලේ නටු මේ මතේ මලේ මේ කැලි වගේ තියෙන ඒවා කළු පාටයි හරිද? ඒ කළු පාට කොහොමත් යනවා රතු පාට තමයි අපිට ඕනේ. එතකොට සුදු පාට මේ පොඩ්ඩ මේ තැන් වල සුදු පාට තියෙනවා. සුදු පාටත් යනවා. රතු පාට වගේ සුදු පාටට හුරු දින ඒවාත් යනවා. Just start tweaking this hue and saturation. Usually value will not be changed much, right? So as you can see, as I mentioned before, let me bring that image. So this is the original image. This is the mask, right? සුදු පාටින් තියෙන තැන් විතරක් මෙතනින් ගලවලා ගන්නවා යන්න. සුදු පාට තියෙන තැන් ටික විතරක් මෙයාකින් ගලවලා අරගෙන තමයි මෙතන මේ තියෙන්නේ. හරි. එතකොට හරි. එතකොට we can play with this, right? මම කෝඩ් එක දාන්නම්. ඔයාලා ඒක ප්ලේ කරලා බලන්න videos ටික. රතු පාට region එක එනකන් විතරක් values change කරලා බලන්න. full code එක ආවේ නෑ නේද? There is a limit to type limit that I can type in the chat, right? So I will give this as a file, right? I'll give this as a file. So you can download this file and start filtering out. So මේ මර දැන් ඩිකේ වෙන්න යන්නේ මෙතන ෂේ වෙලා යන්නනේ හදන්නේ. ඒකෝර ඒක නවත්තන්න. හරි ඊට පස්සේ 175 වගේ තියන්න. saturation පොඩ්ඩක් වැඩි කරාම අර සුදු පාට ටිකක් යයි. රිසල්ට් එක දිහා බලන් ඉන්න. සුදු පාට ටික ගියා නේද? අර තියෙන සුදු පාට මෙතන තියෙන සුදු පාට ඩොට්ස් ටිකක් නැති වෙලා යනවා. saturation එක වැඩි කරනවා. ගොඩක් කරොත් අර ඩිකේ වෙන්න යනවා. දැක්කද මෙතන රතු පාට මේ කළු පාට මෙතන වැඩි වෙන්න ගත්තනේ. ඒතර ඒක ඩිකේ වෙන්න යන්නේ දැන් නවත්තන්න. එරිගානෝ කේස් 100 වැලියු එක ලොකු වෙනසක් වෙන්නේ නැහැ මම හිතන්නේ. වැලියු එක තියන්නේ නේද? saturation එක either so this is how you filter out color from the image. So I will record these values. 175 179 108 255 0 255. This is upper bound and lower bound. upper and lower. Sorry, lower and upper. Lower and upper. Yeah, so this is how you filter out color from the image, right? So next, let's look at let's look at blurring and smoothing, right? Blurring and smoothing. So I will delete this. I'll delete this one and this one. HSV, okay, image. This one and this one. Human will be 175 for me. Humax is 179. Swing will be 108. Value will be 0. Saturation max is 255. Value max is 255. See the range mass. Okay. Yeah, so let's run this. Yep, so now we have result, right? Result. Which is clearly the color filtration of red, right? Okay, so let's do some filtering, blurring and smoothing, right? Not filtering. Let's do some blurring and smoothing, right? There are some blurring and smoothing techniques that we can use to reduce noise, right? So in this case, our target is to reduce noise and blur the image. This result, right? So for that, this image. Okay, so I will do some filter. I will do some blurring and smoothing on this resultant image, right? This image result. To do that, so the first smoothing filter I'm going to use is averaging filter. Averaging, averaging filter. Yeah. basically filter, right? Yeah. So let's do that. Averaging filter. Averaging filter. For averaging filter, we need a kernel, right? Kernel is nothing but a moving window on the image, right? So kernel is like that. So if you dig deeper into the theory, you will understand this what is kernel. What now? I'm not going to talk about deep in kernel. So kernel basically either 3 by 3, 5 by 5, 7 by 7, 9 by 9, likewise. The figures are in odd, right? ඔත්ත සංඛ්‍යාවලින් තමයි මේ කර්නල් තියෙන්නේ. 3 3 වරක් 3, 5 වරක් 5, 7 වරක් 7, 9 වරක් 9, 11 වරක් 11 එහෙම. දෙවරක් 2, 4 වරක් 4 කියලා එකක් නෑ. හරිද? එතකොට කර්නල් තියෙන්නේ එහෙම. එතකොට කර්නල් එක අපි ඩිෆයින් කරගන්නවා. මම np.ones වලින් හදා ගන්නවා. ඒ කියන්නේ ones වලින් තමයි ගන්නෙ. මම 15 by 15 ගන්නවා. 15 by 15. np.float 32. ඔයාලා මෙතන 15 ගත්ත 225න් බෙදන්න ඕනේ. 15 සරක් 15. හරිද? If you for the kernel 15 by 15, you have to divide it by 255. 15 by 15, right? If it is 5 by 5, this should be 25. Likewise. Okay, so this is about kernel. So we are going to write the averaging filter. Okay, for that, so I will choose averaging equal CV2 dot filter 2D and the source will be image result. Needed will be -1. Don't worry about these terms, right? Even I don't know much about the kernel, right? Let's see to the show averaging Okay, let's run this. So this is averaging version of average filtered version of this result, right? If we change the kernel, the result will be changed, right? So as you can see here, the red, so make it තියෙන සමහර කළු regions මේක අඩු වෙලා තියෙනවා පේනවද? There are some black, there are the black regions of the resultant average image is reduced, right? So if you change this to 5 by 5, let's see what will happen. If you change this to 5 by 5, this should be divided by 25. So let's run this. Yeah, so it is not much difference. 15 by 15 is basically good, right? If you let's see what will happen if we enter the even number. Theoretically, there's no such thing called 20 by 20 kernel. It's also working, right? Okay. But basically, these numbers are odd. So this is about averaging filter. So let's talk about next filter that I'm going to use. Gaussian filter, Gaussian blur. Actually, this is blur. Gaussian blur. Gaussian no, Gaussian blur. I call it as blur. Blur equal CV2 dot Gaussian blur. Source will be image result. Kernel. K size means kernel size. Kernel size I will be using 15 by 15. 15 by 15 kernel size. And then the sigma x. I don't know much about sigma x, so I'll give it as 0. So others are default parameters, so we don't want to worry about these parameters. Only these three is enough. And CV2 dot show Gaussian blur, Gaussian blur, Gaussian blurring, Gaussian blurring, blur. Let's visualize this. So this is Gaussian blur. Image, path, result, averaging filter, and this is the Gaussian blur. Gaussian blur. We heavily use this Gaussian blur, right? කළු regions පොඩ්ඩක් අඩු වෙලා තියෙනවා නේද? මේක තමයි ගොඩක්ම අඩු වෙලා තියෙන average field එක තමයි ගොඩක්ම average field එක බොඳ වෙලා වැඩි හැබැයි මේකේ බොඳ ගතිය අඩුයි කළු ගතිය පොඩ්ඩක් මේකට වඩා අඩුයි කළු regions ටික. එතකොට දා Gaussian blur. ඊට පස්සේ medium blur. Medium blur. Median equal C2 dot median blur. Median blur. Image result. The source is image result. Kernel size will be 15. 15, right? Font size, okay. I'll go into the presentation mode, okay. Now I think it's okay. Medium blur. C2 dot show medium blur. Blur. Medium blur, medium. Okay, let's visualize this. So this is medium blur. ඒක අනිත්තරට ගොඩක් හොඳයි නේද medium learning. ඒක තමයි resultant image එක. Averaging blur, averaging filter, එතකොට Gaussian filter, Gaussian blur, medium blur. Medium blur එක ගොඩක් හොඳයි. ගොඩක් ලස්සනට අවිල්ලා තියෙනවා රූපේ. හරි. Medium blur is good choice for this one. Medium blur. Okay, then the last thing that is called bilateral blur. C2 dot bilateral filter. Result will be the source, and the D will be, I would say 15. Sigma color. I don't know about these terms. Genuinely, I don't know. But you can play with these numbers, right? Using track bar, you can play with this number. C2 dot show. So I will say bilateral. I'll save it in a variable called bilateral. C2 dot show bilateral blur. Bilateral. This is a bilateral blur, but there's no any much effect. But I think medium filter is the best one so far, right? So that's about blurring and smoothing. So I'll give this file to you. Just play with this. I'll give this to you. Okay, so I posted in the chat. That's about blurring and smoothing. Okay, so next I would like to talk about morphological transform. Very interesting topic. Morphological transformations, right? Even for this, so I don't need these things anymore. I'll remove these things, and let's see. I don't need image result, but I'll comment this out. So morphological transformations are basically applied for binary images, right? So basically for masks, right? So I have a mask, right? So this mask, so this one, right? This one. So I'm going to use use morphological transformation for this this mask, right? The first one I'm going to use is erosion, right? Erosion. For morphological transformation also, we need to have a kernel. Kernel is nothing but a moving window over the image, right? So there is a theory. The moving window means something like it is a window that produces a mathematical operation over the image, right? So so we need a kernel. kernel, right? Kernel. So for the kernel, I'm going to use kernel equal np.once. Once mean array with numbers with array populated with number one, right? Mm, uh, so I'm going to use a 5x5 kernel. 5x5 kernel. np.uint8. This is a data type. uint8. np.uint8 is a data type. And the first one I'm going to use is erosion. Here is called erosion. Soil erosion වගේ තමයි. පාංශු පාදනය වගේ තමයි. හරිද? Erosion. Erosion. cv2.erode. Erode. Mask. Mask. Source is the mask. Kernel is the kernel. Kernel. So let's visualize this erosion. 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 So what has happened, right? So this is a mask. This is the erosion, right? So as you can see, if you observe clearly this picture, if you compare this picture, these pictures, you can see it is clear that there is a erosion, right? පාංශුපාදනය වගේ තමයි මෙතන. So it is like soil erosion, right? As you can see, the boundaries has been decayed, right? Decayed, right? So boundaries decay, boundaries get decays in erosion. So so that's about erosion. The next one is dilation. 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 v2.dilate. Source is a mask. Kernel will be kernel. Yeah, that's it. Dilation. Okay, so let's visualize this. Where is dilation? Oh, here. So as you can see, dilation did the opposite thing of the erosion, right? Dilation is purora. Dilation is a good choice for reduce imperfection, right? මල දැන් ගොඩක් හොඳට මේ පරිපූර්ණ වෙලා තියෙන්නේ නේද? මලව කන්සිඩර් කරනවනම් මල ගොඩක් highlight වෙලා තියෙනවා කියලා පේනවා. හරි? So if you observe this image, it is evident that the flower is highlighted clearly. So Dilation to the opposite of erosion. There are two more things that I want to discuss. One is opening. Opening C2 dot morphology X source will be mask. Operation will be OP means CV2 dot morph open for opening and the kernel. There's other one called closing also. Closing. So this is close. So let's visualize this opening and closing as well. Opening, closing. This is the opening and closing. Opening is nothing but it's a combination of two operations. Opening means erosion followed by dilation, right? Erosion followed by dilation. That's about that is called opening. Closing means dilation followed by erosion. Okay, so that means the opening means erosion for, so I repeat, opening means erosion followed by dilation. That means the first erosion is taken place. After that, dilation is taken place, right? In closing, it does the opposite thing as the opening. It first executes dilation, then it executes erosion. It's about closing, right? So that's about morphological transformation. So my color detection. So I have a use case called color detection. In that color detection project, so I'm going to use this dilation. So remember this dilation. Dilation fill the gaps, right? Dilation fill the gaps. Since dilation fill the gaps, so I'm going to use dilation for my color filtering project. Color detection project, right? So keep it in the mind. Dilation fills the gaps. Okay, so I will give this code to you. So I posted in the chat. Okay, next thing I'm going to do is contours. I'm going to talk about contours, right? For this you need this image, contour.jpg, right? Make sure you have this image. If you don't have this image, please comment it in the chat, post it in the chat, so that I can send you. You need this image, right? So contours. What is a contour actually, right? I'll tell you in a while. First import CV2. Then then let's read this image called contour.png. Read contour.png. Right, this image contour.png, and I need to have a gray version of this. CV2 dot CV2 color. Source will be image. Two-thirds will be my thresholding level. 255 will be the maximum value. CV2 dot trash binary in. I'm going to use trash binary in mode, right? Then sorry, image CV2 dot color BGR to gray. CV2 dot insure image CV2 dot insure gray CV2 dot gray key 0 CV2 dot destroy all windows, right? So let's run this. So I have the image and the gray version of it. Okay, so yes, I'm going to threshold this image, gray image, because to find the contours, we need to threshold the image, right? Normally, we use threshold. We find contours in a binary image. That's why we are going to threshold this image. So to threshold this, I'm going to call cvt.threshold. So return value thresh. I'm going to call it thresh. cv2.threshold. Gray. I'm passing gray picture. Then threshold value will be, I will be selecting 230, and 255 will be my maximum value, and the type will be cv2 dot trash binary in. Trash binary in. So let's visualize this. Trash. This is the thresholded image. Okay. This is a shoulder image. Now what is known as contour? Contour means a curve joining all the continuous points having same color or intensity. A contour is nothing but a curve joining all the continuous points having same color or intensity. ඒ කියන්නේ එකම color එකක් තියෙන line එකක් එකම color එකක් තියෙන points තියෙනවානේ. එකම පාටක් තියෙන points join කරාම එන curve එකට අපි කියනවා contour එකක් කියලා. දැන් මෙතන contour මොනවද කියලා කිව්වොත් මේක contour එකක්. මේ circle එකම color එකක් තියෙන curve එකක් නෙමෙයි. එකම color එකක් තියෙන points ටිකක් තියෙනවනේ මෙතන. මේක contour එකක්. මේක contour එකක්, මේක contour එකක්. ඊළඟට මේක contour එකක්. දැන් මේ ඇතුලේ යන කොටුවක් තව contour එකක්. boundaries තමයි edges කියන්නේ boundaries තමයි ඉන්නේ. ඒතර මේක තව contour එකක්. contours ඔක්කොම 1 2 3 4 5ක් තියෙනවා. දැන් boundaries තමයි මෙතන මම කියන්නේ අදහස් කරන්නේ. I mean boundaries, right? By contours I mean boundaries, right? There are 5 boundaries which are having same color or intensity. So there are 5 boundaries. So let's see how to detect these boundaries in image processing, right? OpenCV. So hope you got the point. So there are five contours in this image. So let's see how to find these contours. There is a method called cv2.find contours. This method returns true values, right? Which is known as contours. First one will be contours. Contours. Second one will be hierarchy. Hierarchy. And inside this find contours, we have to pass. First one will be the threshold of the image. Then the contour retrieval method, right? Contour retrieval method, I will say cv2. Retrieval tree, right? I will explain this term. Then the last term will be contour approximation method, approximation mode, right? cv2. Contour approximation method cv2. I'll call chain approximation simple. Don't worry, I will explain these terms to you. Okay, so once we once we found the contours, we can once we find the contours, we can draw contours, right? To draw, there is another method called cv2.draw contours. And this one is what is the image that on which I am going to draw contours, right? The image will be img. Then the contours will be contours. Then next one will be contour id, right? Contour id will be -1. -1 will -1 means drawing all the contours, right? Then the color I would say black, 0, 0, 0. Then the thickness I will say 5. Okay, so let's draw this. Let's visualize this. So as you can see, so the contours has been drawn, right? Contours are drawn, right? So in black color, contours are drawn. So the original image was like this, right? Like this. So now you can see contours are drawn. First contours, then contour, then fourth, right? Fifth. Contours are drawn, right? Let's inspect this function, right? So first I will tell you about this draw contour method. Now first I will tell you about these contours, right? This is a tuple with, so I will print these contours, the type of the contour, whether it is tuple or list. As I can remember, it is a tuple contours. Okay? I will comment this out. We run this tuple, right? Tuple. Inside the contours, there are numpy arrays. So I'm going to show you the what is called anatomy of these contours. So this is the result I get. Yeah, it is a huge list, a huge tuple, right? There are how many elements? Let's print the length of this tuple. 5. 5 means 5 contours, right? 5 contours. There are 5 contours, right? So I will access first contour. Let's print this out. So there are number of coordinates, right? So there are 1, 2, 3, 4 coordinates, right? There are 4 coordinates. Okay, so these are the points in the contours, right? In draw contours, what it does is connecting these, joining these points together, right? That's what draw contours does. This function, right? Okay, so I want to dig deeper into this CV2.find contours, right? Okay, so I draw the contours with thickness 3. Okay, so this is a contour retrieval mode, right? Contour retrieval mode. So there are number of retrieval modes, but I will talk about only two of them. So this one is retrieval tree. The other one will be retrieval external, right? So in external, let's see what will happen. So it will draw only the outermost contour, right? It is known as external, right? So that's what this retrieval external means, right? So if you pass cv2.retrieval tree, it will give you all the contours, right? Because my contours function again, to function again, retrieval mode කියලා එකක් තියෙනවනේ මෙතන මේ දෙවෙනි පැරාමීටර් එක. retrieval mode එක external දුන්නාම external දුන්නාම outermost contour එක විතරයි එන්නේ. retrieval tree දුන්නොත් ඔක්කොම contours එනවා. ඔක්කොම contours draw කරලා එනවා. හරිද? ප්‍රශ්නයක් තියෙනවා. Can't we change the color of the contour? Of course you can. To do that, so here we have to pass the BGR value. So I chose 0, 0, 0, 0, right? So to draw this in some other colors like 255, 255, 255. So this is the color. This is the color you are drawing the contour. This is the parameter to change the color of the contour. Okay, so for the time being, I put 0. So that's the difference between retrieval mode, right? Between the retrieval tree and retrieval external, right? Then what is this chain approximation? Chain approx simple, right? There are two things called chain approx none or chain approx simple, right? So what does it mean? So let me explain, right? So to do that, so I comment this cv2.contours, draw contours. I'll print this yeah, before that I have to show you some other thing. So this will print all the contours, right? This will print all the contours. You can print each contours by giving the index of each by giving the index, right? So if you give index 0, it will print only the first contour. If you enter 1 here, it will draw only the second contour. Likewise for 2, if you enter 2, it will draw the third contour. So there are only 5 contours, right? The last contour will be 4. If you exceed the number, let's see what will happen. So there will be error, right? So to draw all the contour, you have to put -1. Okay. That's about this contour ID. So I discuss about the anatomy of these contours, right? So it is a tuple with lots of coordinates, right? So I will access the first contour, and I will, so it is a numpy array. So I will draw the shape. I will inspect the shape of this array. Shape means the dimension. So let's so I'll comment this out. Let's run this. So it is a 5 by 1 by 2. sorry, 4 by 1 by 2. 4 means there are 4 coordinates. There are 4 coordinates in this contour. 1 means there's a 1, which is the size of this array. Okay, there is a 1 and 2. 2 means there are 2. The coordinates have 2 numbers. So that's why this 2, right? So 4 by 1 by 2, right? So what I'm going to do now is so I'm going to initialize this contour 1. First, let me I will consider the this is the first contour, this is the second contour, this is the third contour. So I will consider this third contour, which is a triangle, outermost triangle. So 1, 2, 3, right? 3, third one. The index is 0, 1, 2. Index is 2, which is third triangle, which is third contour. So the index is 2. So I'm going to use this one. Index is 2. Okay, let's run this. So there are 558. There are 558 points, right? We can plot this. To plot this, so I have a technique called reshape for that before visualizing this. So I consider C equal contours 2. I need to reshape this. Reshape, what is mean by what is the meaning of reshape? Reshape means the change in the dimension of the array, right? So this array has the dimension of this array is 558 1 by 2, right? I have to reduce the dimension to 2 dimension. Here there are here the dimension is 3. I need to reduce the dimension, reduce this dimension to 2, right? Okay, make a dimension එක 3ක් තියෙනවා. dimension එක 3ක් නේ. මේ 3 dimensional array එකක් නේ මේක. මේකේ size එක බලුවාම මට මේක dimension එක දෙකකට දාගන්න ඕන. හරි. ඒ කියන්නේ මට ඕනේ මේ coordinates වල නිකන් array එකක්. නිකන් එහෙම. එහෙම දාගත්තම මට ලේසි වැඩේ කරන්න. එතකොට මම මේක reshape කරනවා මෙහෙම -1 2. මෙහෙම දැම්මහම -1 එකේ අදහස් කරන්නේ මේ මොකක් හරි any value එකක් කියන එක අදහස. -1 represent any value. 2 means I want to reshape it to 2, right? Reshape. I need to my dimension of this array should be 558 by 2. That's the meaning of this statement, right? For this case. So it will be 558 by 2. If I run this, okay. So I print this, print c.shape. So the shape will be 558 by 2, right? So now what I'm going to do is I put a circle on each point. fill circle in each point so that I can view it as a point, right? මට මේක point එකක් විදිහට පෙන්නන්න ඕනේ. මේ plot කරලා පෙන්නන්න ඕනේ. හරි? plot කරලා ගන්න ඕනේ. හරි? ඒක කරන්නේ කොහොමද? point cloud එකක් විදිහට පෙන්නන්න ඕනේ. ඒතකොට මම මේක c2.circle c2.circle circle image is image, center will be x comma 1. We have to loop this in array, sorry, loop for xy in c, xy in c, radius center will be x comma y. The next thing I think what is the next thing? Radius I would say 3. Then what is the next thing? Color and thickness. Color I would say blue. Blue means 255 00. Thickness will be -1. Minus 1 means fill circle. So let's visualize this. So as you can see, these are the points in the contour, right? So it okay, so for the first contour, let's see for the first contour. First contour, these are the points. Only 4 points are there. But for the triangle, there are lots of points. There are lots of points in the contour, right? So what this chain approximation simple means, you will realize what is it, why, what is it. While so another approximation method is chain approx none. So let's run this. So as you can see, now there are 11,1121 points, right? There are huge points. Previously there were only around 500 points, right? 500 and something, right? So this so the for chain approx simple, for chain approx simple, there will be only this number of points. Okay, so let's consider for the circle also. Circle is the fourth one. Chain approximation simple will have this number of points. There are only 150 points, right? 150 points. But if I enter one approx none, it will return all the points. මේ chain approx simple එක chain approx none එකයි අතර වෙනස තමයි මම මෙතන පැහැදිලි කරේ. chain approx none එකේදී ඔක්කොම points එනවා. ඒ contour එකේ තියෙන ඔක්කොම points ටික අර contour එකේ include වෙනවා. හැබැයි chain approx simple එකේ සීමිත ප්‍රමාණයක් කියන්නේ මේ පොඩි ගාණක් කියන්නේ. Simple. As the name suggests, it's simple. The number of points are less, rather than chain approx none. Number of points are less, right? So that's the difference between these two. Okay, so So now hope you understand the theory. For the let's visualize for the first contour also. In chain approx simple, there are only 4 points in the contours. Right? Chain approx none will return all the points. All the points. That's the difference between these two. So I hope you got the point. So this is about this hierarchy has the information of contour topology. Contour topology. Contour topology means there are so මේ hierarchy එකේ තියෙන්නේ contour topology එක ගැන විස්තරයක්. Topology කියලා කියන්නේ මේ contour එක ගත්තොත් මේ contour එක මේ contour එක තමයි පිටින්ම තියෙන contour එක. මේ contour එක ඇතුලෙන් තියෙන එක තමයි මේ contour එක. ඒතර මෙයාගේ child තමයි මෙයා. ඉතින් මෙයාගේ child තමයි මෙයා. මෙයාගේ child මෙයා. මෙයාගේ child මෙයා. මෙයාගේ parent මෙයා. මෙයාගේ parent මෙයා. මෙයාගේ parent මෙයා. මෙයාගේ parent මෙයා. අන්න ඔය ඕක ගැන විස්තරයක් තමයි තියෙන hierarchy. ඒක ඉතින් ඔයාලා දැන්ට වැදගත් වෙන්නේ නැහැ. So the hierarchy has the information about contour topology, whether it is a parent or child. So this contour will be a parent for this contour. This contour will be a parent for this contour. This contour will be a parent. This contour will be doesn't have a child. This contour, the parent of this contour will be this contour. Parent of this contour will be this contour. Parent of this contour will be this contour. This contour has a child, which is this one. This contour has a child, this one, right? There is a parent-child relationship. So the hierarchy has this relationship. So you don't need it in this case. So hierarchy, keep it in mind. Hierarchy has the topology of information of the topology of the contours, right? Okay, so okay, so next thing that I want to show you is contour approximation. There is something called contour approximation, right? So we need these things for shape detection, right? That's why I am teaching these things for the let's see about contour approximation. What is the contour approximation? Contour approximation is I'll tell you in this example. So I'll put this chain approx simple, and I will choose second contour. So there are 558 points. 558 points. We don't need such number of points to to detect a triangle. So I'm going for shape detection, right? So let's select shapes, right? So triangle එක අඳුර ගන්න ඔච්චර points ගානක් ඕනේ නෑනේ අපිට. හරි? We don't need such number of points to detect a triangle. Only 3 points are enough, right? Only 3 points are enough. To reduce the number of points, there is a method called, there is a technique called contour approximation. So that's what I'm going to show you. Contour approximation. For that, we need to calculate the perimeter of this triangle, right? Peri CV2 dot arc length. So my arc will be C. This is my arc, and it is the next parameter is the indication of whether it is connect, whether it is close arc or not. So it is a close arc. So I'm going to put through here. So peri C, comma through. Then I'm going to use approximation. So CV2 dot approx 40 dV. Approx 40 dV. Here I have to pass the contour, which is C. Then epsilon. Epsilon means epsilon is I'll tell you. So I view it as 0.04 times peri. It is a function of peri. Peri means perimeter, and again it is indication of whether it is close or not. So it is close, so it is through. So approx is there. I comment this out. Okay, so I'll print the number of points before the approximation and after the approximation. Right? Before the approximation, number of points before the approximation. Then let's see a number of points after the approximation. then approx. Let's run this. So before the approximation, there are 558 points. But after the approximation, there are only 3 points, right? That's the beauty about this function, right? So it approximates the contours, right? So let's visualize these points. Approx. I'll reshape this. Approx reshape. So this is the point. These are the points, right? So as you can see, so if you can't see it properly, I'll increase the size. So there are only 3 points, right? After the approximation, there are only 3 points, right? Before the approximation, there are how many points? 558 points. Okay, so let me visualize this it also in a different color. So these are the points before the approximation. Red, the points before the points which are in red are before the approximations, right? After the approximation, there are only 3 points. Only these 3 blue points, right? So that's pretty much that's the beauty of this approx for DB method, right? So what is this 0.04 times Perry, right? What's this? It is a value that governs the algorithm behind this contour approximation. It is a function of, basically it's a function of perimeter, right? We can use the perimeter to get the, we can play with this result, play with this value. ඔයාලට මේ value එක මේ වෙනස් කරලා බලලා results බලන්න පුළුවන් මේ මොකද්ද හොඳ කියලා. හරි. 0.04 සාමාන්‍යයෙන් shape detection වලට හොඳ. සාමාන්‍යයෙන් මේ පරිමිතිය වගේ 0.04 විතර ගත්තොත් හරි. හරි. ඒකෝට මේ shape detection වලට මේක පාවිච්චි කරන්න පුළුවන්. හරි. එතකොට ඔය ටික තමයි මට කියන්න තියෙන්නේ මේ contours සම්බන්ධයෙන් වෙලාව නම් මදි තව පැය භාගයක් තියෙන්නේ shape detection තියෙනවා face detection තියෙනවා color detection උත් තියෙනවා. බලමු පුළුවන් තරම් කරන්න. Okay, so that's about this. Let's jump into shape detection, right? So shape detection. So for shape detection, I have a file called shapes.png. So it has a bunch of shapes, which is square, circle, triangle, rectangle, oval, and a pentagon, right? So let's detect these shapes one by one. To do that, import CV2, then image will be CV2.inread shape.png, right? This file shape.png, shape.png. Then I need the gray version of it. CV2.cvt color ing cvt.color agr to gray. This will be the gray image. Next, I will apply some blur so that we can detect shapes properly. So we have to blur it, Gaussian blur, gray, kernel size will be 5 by 5. And sigma x will be 0. Then I will use canny edge detection. Canny CV2 dot canny. What is so what is being detected? It is blur. Threshold 1 will be 50. Threshold 2 also will be 50. You can play with this number. Then the contour approximation. So I will copy paste the code so that we can complete this fast. Okay, let's visualize this scanning first of all. So this is a edge detected image, right? So using this, we can find the contours. Okay, so the idea, so so the algorithm behind this shape detection is first we have to find out the contours. First, we have to find out the contours. Then we have to approximate the contours so that we will find the optimal number of points for the shape. So for this point there are 5 points. There should be 5 points. For this shape there should be many points. For this shape there should be 3 points. For this shape there should be 4 points. For this shape there should be many points. For this shape there should be uh, 5 points, right? So we have to do contour approximation, right? To get the optimal number of points. By counting number of points, we can determine with it is a we can determine which shape it is, right? Uh, so CV2, so I contours. I'm finding contours from this line. I'm performing the external one. The contour approximation, contour retrieval mode is external. If you use tree, there will be many contours. You should only get 6 contours, right? There are only six shapes, so we should only get 6 contours. So if I pin this length of contours, so there are only 6 contours, right? So we are okay with that. So there are only 6 shapes, right? So okay. Now if you enter here tree, see what will happen. There are 12 contours. That means this outer contour and inner contour. This outer contour and inner contour. Outer inner. Outer inner. Likewise, there are 12 contours, right? But we need external contour. So that's why I use external here. So okay, so uh, next I'm going to write a method, right, to detect the shape. If detect shape, C is a contour, C means contour, and the shape will be this is a placeholder for shape. So it is a string. It's an empty string for now. So we calculate peri, same as before, for the contour approximation. Peri equal, I'll copy paste the code. Now these things are familiar to you. Peri and approx, and for the triangle, length of approximate 3. There are 3 points. If there are 3 points, it should be a triangle. It should be a triangle. square and rectangle. There is a problem here. Square and rectangle both have 4 points. So how to detect square and triangle independently, right? So that's the question. Let's answer this. So else if length approx equal to 4 there is a method called cv2.bounding rect. cv2.bounding rect. cv2.bounding rect. Bounding rect, and I pass the approx here. Approx here. So it will create a bounding box around the shape, right? So this will give this will give, or this will return x comma y comma w comma h, right? This is like this. So for the rectangle or square, so the approx length of the approx will be 4. So so there are two cases, right? So then this bounding rate, what it does is it create a bounding box. It determine the values for bounding box. It determine the values. It determine the coordinates to create a bounding box around this shape, right? Around this object, right? So for example, make a, you can cv2.bounding box කියන එකෙන් bounding rect කියන method එකෙන් කරන්නේ මේක rectangle එකකින් වට කරන්න ඕන coordinates ටික දෙන එක තමයි කරන්නේ. ඒකෙදි මේ මෙතන ඉහළ coordinate එක දෙනවා. ඉහළ coordinate එක දෙනවා. ඊට පස්සේ ඒකේ width එකයි height එකයි දෙනවා. මේ width එකයි මේ මුල්ල ඉතුරු දැන් මේක මෙහෙම කියන්නේ. මේක bounding box එකකින් අඳින්න නම් මේක කොටු කරන්න නම් point දෙකක් ඕනනේ. point දෙක තමයි මේ point එකයි මේ point එක. ඒතකොට එයා දෙනවා මේ cv2.bounding rect කියන එකෙන් දෙනවා මෙතන මුල්ලේ point එකයි xy coordinate එකයි මෙතන මුල්ල ගන්න ඕන width එකයි height එකයි. මේ width එකයි මේ height එකයි. මේ width එකයි height එකයි. එතකොට මට width එකයි height එකයි එනවනේ. width එකයි height එකයි බෙදලා මට පුළුවන් ඒකේ aspect ratio එක බලලා ඒක square එකක්ද rectangle එකක්ද කියලා කියන්න. හරි. ඒතකොට මේකෙත් එහෙමයි. දැන් මේකෙත් මම bounding rect එක ඇදලා පෙන්නන්න. වෙලාව නැහැ. අදින වෙලාවක් නැහැ. මෙතන මේ මුල්ලේ coordinate එකයි මේ මුල්ලේ coordinate එකයි ගන්න ඕන parameters ටික දෙන එක තමයි. ඒ කියන්නේ sorry මේ shape එක අඳින්න මේ shape එක rectangle box එකකින් වට කරන්න ඕන coordinates දෙන එක තමයි cv2.bounding rect එකෙන් කරන්නේ. හරිද? එතකොට ඒකෙදි මෙතන මේ coordinate එක දෙනවා. මෙතන coordinate එක ගන්න මේ width එක height එක දෙනවා. එතකොට මේක මේ x plus width y plus height එකෙන් මේ point එක ගන්න පුළුවන්. එහෙම තමයි මේ cv2.bounding rect එකෙන් දෙන්නේ. ඒ values තමයි දෙන්නේ. ඒතර wh දෙන හින්දා width එක height එක දෙන හින්දා width එක height එක බෙදලා අපිට පුළුවන් මේක rectangle එකක්ද square එකක්ද කියලා බලන්න. ඔය වැඩේම කරන්න පුළුවන් circle එකටයි oval එකටයි කරන්නත් පුළුවන්. හරිද? අපි ඒක කරලා බලමු. aspect ratio AR W බෙදීම H. shape එක square එකක් වෙනවා. AR සමාන 1. else rectangle. මෙතන AR සමාන 1 දාන්න පුළුවන්. ඒ වුණාට ඔය side deviation එකක් වෙනවනේ. මේක දැම්මහම හරියටම වෙයිද කියන්න බෑ. ඔය aspect ratio එකේ side variation එකක් වෙන්න පුළුවන්. හරිද? ඔක perfect square එකක් වෙන්න කියන්නත් බෑ. මොකක් හරි ප්‍රශ්නයක් ඉන්න මේක 1 දාන්නේ නැතුව මෙහෙම කරනවා අපි. 0.95ට වඩා වැඩි හෝ එකයි දශම බිංදුව පහට වඩා වැඩි. එකයි දශම බිංදුව පහට වඩා අඩු. කොහොමද එනවා? හරිද? මේකම කොපි කරලා මම දානවා ඒක මම පස්සේ දාන්න. else if then approx පහක් නම් points පහක් නම් pentagon. else නම් circle එකක් හරි oval එකක් හරි. points පහට වඩා වැඩි නම් ඒක circle එකක් හරි oval එකක් හරි. circle එකකත් aspect ratio එක මේ range එකේ තියෙනවා. oval එකක් නම් ඒ aspect ratio එකට වඩා වැඩි. එතකොට මේක එහෙම දෙනවා. ඊට පස්සේ return shape. now it's okay. මේ කෝඩ් එක කොපි කරන්න. මම මේක පැහැදිලි කරන්න. හරි. මේක හරි. ඊට පස්සේ මේක රන් කරමු. හරි නේද? Now we are correctly getting the relevant shapes, right? Square, circle, triangle, rectangle, oval, and pentagon. I don't have time to do the deep learning part today. Also, there are color detection and shape detection as well. I'll demonstrate these two to you. First, color detection. Don't worry, I will create a IPython notebook for you so that you can learn things by yourself. Okay, so if I run this, this is the color detection code. It's a only few extension. This is a few extension to the color filtering code. So if I run this, so here blue color. As you can see, it detects as blue, green, and red. Right, red. The other one I want to show you is face detection. Face detection is this code. It is based on R cascades, right? There are some files called R cascades. They are XML files. They have attributes to find the particular, for example, it is a number. It can be a number plate. It can be a face. It can be eye. So for this code, I use both the face cascade and the eye cascade. Right? There are files. So this is the link for R cascade. So I will post it in the chat. So you can download the R cascade file from here. So there are some existing good R cascade files. So if I run this, eyes are detected in green color box. Face is detected in blue color box. Don't worry, I will give you all this code so that you can understand. Unfortunately, we don't have much time for this. Actually, I thought to do. I thought to do deep learning part today, but there is a limited time for that. It takes some time. So don't worry, I will prepare the notebook and I will give to you before end of this month. Join to the WhatsApp group, right? I will post that file to the WhatsApp group. Also, we can email if you want. We have your emails. We can mail to you. I will create the IPython notebook by providing with proper theory along with the code. So that will be the best way to I think to gather the knowledge. Okay, so let me show you this link. So there are a number of cascades files here, right? Full body, face, left eye, plate, right? Lower body, profile, right eye, Lucian plate, Lucian number plate detection, smile. To detect smile, we can use this smile cascade. So there are a number of cascade files. So you can use with you have to call this detect multi-scale, right? So that's the only thing you have to understand, right? So that's about it. So if you have any question or any comment regarding this workshop, you can post them into the WhatsApp group. I can help you out. So that's about it. Thank you for joining. Have a nice day. There is one more question. Okay, I'll send the files. Okay, I will. Wait. Color detection and face detection. So I have I have send the two files to the chat so that you can learn. I think those are the two things I miss in this section. Yeah, so that's about it. That's about the basic image processing. Yeah, I will keep you updating this WhatsApp group. So please join to that group if you are not a member. Yeah, so that's about it. So I will wrap up the session. So thank you.
Thank you very much, Engineer Chulendra Wibhavashakthi. Actually, thanking is not enough for this valuable support. So I would like to invite Vice Chairman of the Robotics and Automation Student Branch, IEEE Student Branch of University of Ruhuna, Mr. Vilochana Zigera, to deliver a vote of thanks.
Good evening, everyone, to one and all who are present here. On behalf of the Robotics and Automation Society of IEEE University of Ruhuna Student Branch, I extend my gratitude to Engineer Chulendra Wibhavashakthi to take out his time from his busy schedule to grace this event. Thank you, sir, for educating us in computer vision and image processing in a very simple and a captivating manner. A special thanks goes to Mr. Eranda Jayatunka, Head of the Department of Electrical and Information Engineering and Senior Lecturer, facilitating us to make this webinar a success. And I extend my gratitude to the President of IEEE University of Ruhuna Student Branch, Mr. Ruhanta Jayavira, and President of Robotics and Automation Society of IEEE Ruhuna Student Branch, Mr. Gihan Rupatunga, and all the other members of the organizing committee for organizing this workshop. Finally, thank you to all the participants for making this event a success with your participation. And there's an announcement, as we have mentioned earlier, the recordings of the two sessions and the prepared notebook will be added to the WhatsApp group within a couple of days. Hope you learned a lot from this event, and have a good night. Thank you.
Thank you, Mr. Vilochan Sigera. So we have come to the end of our workshop. So hope to meet you for another valuable session soon. Thank you very much and stay safe.